I'm Anil Kumar, and I hope with the help of this video, the struggle of my students sketching transformed trigonometric functions will come to an end. So there have been many requests for this video. So I will show you a technique which is going to make things so simple for you that you'll start loving sketching transformed trigonometric functions. So the question here is, sketch graph of f of x equals to 2 times cos x over 2 minus pi by 12 minus 3 within a time period of 0 to 2 pi. So what we will do here is first analyze the function and then sketch it. So what we are given here is f of x equals to 2 cos. Now always I prefer to factor out the term here, which is half. When you factor half, you get x here minus pi by 12 divided by half. That means it is pi by 6, correct? That is what you get, minus 3. We'll look into this part later. Let's first discuss the function itself. Now, well, for some of you, this may be a critical stage. You can check your answer. If you open the bracket, you get half x minus, if you multiply half by pi by 6, you get pi by 12. So that is correct factoring. Perfect. So that is how you factor half from this unit. Now as you can see from here, we have a, the amplitude equals to 2, x's, which is the value of c, as minus 3. So what really I'm comparing it with is a general trigonometric function, which let me write on the top itself as cos of a times cos of k x minus t plus c, right? So a means amplitude, c means x's of for the cosine function, right? Now d is your phase shift, so d is minus pi by 6 means pi by 6 to the right, and from here half is the value of k, so k is half for you. The value of k helps us to find the time period t, which is 2 pi by k. Those of you who are doing with degrees, they can write 360 divided by k, so that means 2 pi by half, that is 4 pi, right? So in radians it is going to be 4 pi. If you do it in degrees, then it will be 360 by k, which is 360 by half, or 720 degrees, correct? Anyway, so that means 2 time periods, perfect, will be the time period for one wave. So within 0 to 2 pi, actually you get only one of the waves, half the wave, correct? Now that is what you have. Now knowing all these things makes things simpler for us. Let us now sketch this function. Now from here you can also see few more things. If the axis is at minus 3 and amplitude is 2, what is the maximum? So the maximum should be equals to the axis plus the amplitude. So minus 3 plus 2, which will give you minus 1. And the minimum value will be axis minus amplitude. So minimum is minus 5 for you. So these are critical parameters, the maximum, minimum, and the time period, which we are going to do in radians. Perfect. Since we see that the axis, maximum, minimum are all negative, let me draw the x-axis right here on the top of the page, and let this be my y-axis. Perfect. Now what I notice here is that the numbers are 1, 2, 3, 4, 5. So let me take a scale which each unit has 1, 2, 3, 4, 5. That's the minimum for me, right? So now let's start sketching function one by one. Begin with axis, which is at minus 3. So this is minus 3 for us. So let me draw axis here. That is the axis for the given cosine function. Now maximum will be at minus 1, so this is minus 1. So I'm just drawing dots here indicating that somewhere along this line I'll have maximum, and somewhere along this line I'm going to have minimum, which should be at minus 5. Perfect. Now We are given a cosine function, so I will draw two graphs. First, without horizontal transformation, and in the second part we will transform, right? So I'm not dealing with this part, but I'm only dealing with this part of the function, right? So that means two cos of this without horizontal translation. The cosine function starts with the maximum, so I can start with the maximum and I can go like this. So that is my one wave. Perfect. Now this particular one wave which I have drawn should be starting at 0, right? Since I have not incorporated the factor of horizontal translation d, so I will start with 0. Time period is 4 pi. So it ends here, which is 4 pi for us. Half of it will be at 2 pi. 1/4 of it will be at pi. 3/4 will be at 3 pi. Perfect? Right. So we get, this is the graph for the function. Let me write down. Of function 2 cos pi x by 2, right, minus 3. So this is the function which I've drawn. Now what I will do is incorporate the horizontal translation of pi by 6. Now if that much is pi, then I can divide it to 6 portions. This is pi by 2 and then 3 portions. Do you see that? So that small portion is my pi by 6. So every point gets translated right by pi by 6. Do you see that? That is my additional pi by 6. Do you get the idea? So it ends at, let me calculate here, 4 pi plus pi by 6, which is 4 times 6 is 24 plus 1, 25 pi by 6. So that is this point, 25 pi by 6. Perfect. Every point shifts, so I can actually join these points and draw my transformed final function. Do you see that? This function. So this is for us the given function, which is 2 cos, I can write as I wrote here, half x minus pi by 6 minus 3. Do you see that? So I will recommend that always sketch it in two parts. One without horizontal translation and finish it off with the horizontal translation. That makes things very simple. So that is your final answer. I hope with these steps you clearly understand how to sketch transformed trigonometric function. While in addition, we could have few questions here saying what is maximum, what is minimum, what is domain, range, all those things which can be answered easily. You can see that the range of the function is from -1 to -5, both included, right? And the time period of the function is 4 pi, correct? So when we say sketch this function to up to 2 pi, you will sketch just half of it, right? So it will have half the wave. When we say sine cos of half x, right, it means it will have half the wave in 2 pi time period, right? But I like to sketch the whole wave here to show you in completeness how it looks like. I hope you appreciate and understand the concept. Do some practice problems from the book and write to me if you have any more difficulties regarding this. Thank you and all the best.